Hi class, this is course 2, lesson 9. Today we're going to add, subtract, and multiply fractions, and we're going to talk about reciprocals. So when you add and subtract fractions, remember that you need to have the same denominator. And all of the examples from lesson 9 will have the same denominator, and we'll get into needing common denominators later, but you need to know no matter what, if you add or subtract fractions, you have to have the same denominator. So here are a few examples. Notice in the first example we have 2/7 plus 2/7 plus 3/7. And we notice that the denominators are all the same. So we're just going to have more of the pieces that have been created for us in those groups. So if you could envision like a pizza that was cut into 7 equal parts, we have 2 pieces, then we have 2 more, and then we have 3 more. And so when you add, we're going to add the 2 plus the 2 plus the 3, and we're going to end up with 7. And then we just keep the denominator because we didn't change the size of the pieces. We just have some more of them. Now, anytime you end up with the numerator and the denominator being the same, that's going to simplify to 1. We have 7 pieces out of 7 possible pieces, so we have the whole thing. My other addition example is percents. We have 33 1/3% plus 33 1/3%. So here we have some mixed numbers. And when you add mixed numbers, we're going to add the fraction pieces. So 1/3 plus 1/3, we have common denominators. So add the numerators. 1 plus 1 is 2. And you keep the denominators, so we have 2/3. Then you add the whole number parts. So 33 plus 33 is going to give you 66. And then remember that we need a label. Because these were percents, our answer should be percent. When you work subtraction problems, same basic process for now. Notice that you have the same denominator. And here we'll do mixed number minus mixed number. Same process. Take your first fraction, 5/9, and subtract 1/9 from that. 5 minus 1 would be 4. And we're going to keep the denominator. Now don't forget to subtract your whole numbers. 3 minus 1 is 2. On the bottom, our last example, we are subtracting fractions, and you notice that the denominators are the same, so we can subtract. Subtract your numerators. 3 minus 3 is 0, and keep the denominators so we have none of the pieces out of 5 pieces possible. Anytime you have a numerator with 0, we just want to write 0. When you multiply fractions, here are some key things that you need to know. Do not change your denominators. For right now, we're just going to look at this as multiplying across. So we're going to multiply numerators, and then we're going to multiply denominators. We will get to a point where we can simplify, but not yet. Here are 2 examples. Notice that the first example, 1/2 of 1/3, doesn't even have multiplication in there. But you need to know, and maybe you already do, that the word of means multiply. So this problem is really 1/2 times 1/3. And so then we're going to multiply. Don't change the denominators. We're going to multiply numerators. So 1 times 1, 1. And we're going to multiply denominators. 2 times 3 is 6. Second example, we have 3 fractions that we're going to multiply together. And all the rules stay the same. We just multiply across the numerator, multiply across the denominator. Again, we'll get to a point where we need to be looking to simplify, but not today. 1 times 3 times 1 is 3. And then multiply the denominators. And you can do this in any order. You could look at it and say, oh, I want to multiply 4 times 5 because that's 20. And then I'll multiply that by 2, which is 40. You could go straight left to right. 2 times 4 is 8 times 5 is 40. You could do, let's do 2 times 5. That's 10 times 4 is 40. Anytime you're going to move those around, you're talking commutative property, and that is completely fine. Here's the other piece that we need to talk about is reciprocals. And to make a reciprocal, we're going to invert a fraction. And that process of inverting is switching the numerator and the denominator. So let me give you some examples. So if we start with a fraction of 2/5, the reciprocal would be switch those two positions. So the 5 would become the numerator and the 2 would become the denominator. If we start with 1/4, now don't put an equal sign in here because these are not equal. They are reciprocals. 1/4, if you reciprocate those or invert them, the 4 becomes the numerator and the 1 becomes the denominator. And anytime you have a fraction over 1, you know that, and here I can use the equal sign because that is 4 groups of 1s, which is 4. Now if you start with a whole number like 7, you know that is 7 over 1, 7 groups of 1. So the reciprocal then would be 1/7. The inverse property of multiplication. So remember in lesson 2 we learned some properties. Now we are adding a new one. It's the inverse property of multiplication. And that property says the product, so we're going to multiply, of a number and its reciprocal is 1. And here's what the book says, and don't worry about this thing. The book says a number times its reciprocal is 1. And a can't be 0 because we can't divide by 0, but don't worry about that either. So let's take a look at multiplying some of these examples we used just above. So if I take 2/5 times its reciprocal, I'd get 5 times 2 is 10, and 5 times 2 is 10, and 10 divided by 10 is 1. Down here, this is another type of problem the book is going to ask you to do. So it's finding the missing number, but here's where you use the inverse property. 4/5 times a number is going to equal 1. Okay, so if we didn't know that the inverse property of multiplication existed, we'd know that we need to have a fraction as our result so that we'd end up with the same number in the numerator as in the denominator, so that when we simplify we'd get 1. But since we know the inverse property says a number times its reciprocal, so if we take 4/5 times its reciprocal, the 5 goes in the numerator, the 4 goes in the denominator. If we multiply that, we would get 20 over 20, which equals 1. So the missing number, n, equals the number that we substituted there or problem solved through. N equals 5/4. Okay, and the last thing we need to talk about. You're going to see problems like this, and they are going to be how many 3/4 are in 1. And you can't say that there are 3/4 or that there are 1 3/4 because I know some of you are going to say, well, if I have a whole, I can only fit 3/4 in there. So that would be 1. That is not the same as what they're asking you for. They're asking you how many 3/4 can fit into 1, like how many times would you be able to divide 1 by 3/4? But we don't need to do that yet. What they're asking you to do is this problem. 3/4 times what number would equal 1? And we know that using the inverse property, if I put 4/3 in here, when I multiply, I would get 12 over 12, which equals 1. So the answer to these problems is whatever they're asking you to do, tell me what the reciprocal is. So, how many 3/4 are in 1? There are 4/3. And we'll learn how to do that problem much more clearly when we talk about dividing fractions. That's it for lesson 9. I will see you in class.